These are the new symbols we learn in this unit about inequalities. Less than or equal to, greater than or equal to. Notice for the less than graphs, they both go to the left to smaller numbers. This top one has an open circle, this bottom one has a filled in circle because of that line. That includes the number 7, whereas this one does not. The same thing happens with greater than or equal to. That line means you fill in, no line, open circle. -4 is not included, -4 is included. So the steps to solving these are very much like the equations. We're going to distribute and combine like terms. We're going to move the variable to one side, and then we'll follow the reverse order of operations. One key difference is the idea that we have to flip the sign when we multiply or divide by a negative. Let's look at a few problems. So here I am first going to add 2m to both sides. This gives me 4 is less than 4m. If you aren't paying close attention, you might see a less than symbol in the m and think we're going to the left. But if we rewrite this, well, I guess we could divide by 4 first. So we have 1 is less than m. We can also write that as m is greater than 1. If our number line is here at 0, 1, and 2, we are actually heading to the right. What's going on here? Why is this different? Well, notice that my variable is on the right. In all these examples, which I have since deleted, the variable's on the left. So sometimes it helps to rewrite it like this. The arrow should be going to the right. Move the c's to the same side. -4 greater than 4c plus 4. Now it's like a two-step, -4. -8 is greater than 4c. Divide by 4. -2 is greater than c. If I want to rewrite it with c on the left, remember that the inequality has to change its orientation. First thing I do is distribute the 3's on each side. This gives me 6 minus 3p is less than 6 plus 3p. Notice -3 and plus 3p are different. So let's say we do plus 3p on both sides. This gives me 6 is less than 6 plus 6p. If I subtract 6 from both sides, I have 0 is less than 6p. If I then take this and divide by 6, I still have 0 is less than p. If I wanted to rewrite it with p on the left, the inequality sign has to flip. If I subtract 3d from both sides, the d's go away. Not just the 3's, also the letter. Is -8 less than 4? This is either a true or a false statement. This one is actually true. That means there are infinite solutions to this inequality. Make sure you cancel out the letters first before you try to move numbers for this reason. This is a compound inequality. If I subtract 4 from the middle, I also subtract 4 from the right and from the left, all three sides of this compound inequality. I'm left with 6 is greater than or equal to p is greater than -1. Same thing here. I'm going to do a plus 5 on all three sides. So I have -2 is less than t is less than 12. So let's put a -2 over here and a 12 over here, put some open circles on each of them and connect them. This graph shows the intersection whenever t is greater than -2 but also less than 12. With ORs, it's going to work a little bit different. I solve them both separately. Add 4 minus 1. I have r is greater than 7 or r is less than -5. So if I was to make a graph and have -5 and 7, I'd be going away from each other. It's not the intersection. Only one of these has to be true. First thing I do is distribute. This gives me 5c plus 10 is greater than 5c plus 15. If I subtract 5c, I always recommend canceling out the letters first. Is 10 greater than 15? No, this is a false statement, so I'm going to write no solution. To write these, I'm going to say that x is less than -2 or x is greater than or equal to 4. With this one, this is the intersection, so it's all of the numbers that are both bigger than -5 and less than 5. This fails the vertical line test. A vertical line touches the graph more than once. That means this is a relation. This one passes the vertical line test. It's a function. Any point you have a vertical line, it only touches the graph once. If we look, the only repeating x values have the same y values, so this is a function. Here we can see that we have the same x value with different y values. That breaks the rules. This is not a function, this is a relation. For this problem, if x is 5, we can substitute in there, and we have 3 times 5 minus 12, which is just 3. 15 minus 12 is 3. Here I'm going to plug in a negative 3. The tricky part is I have to put parentheses. If I don't, then I'm going to do the negative incorrectly, because this is the same thing as 2 times 9 plus 1, or 19. G of 3 means plug in a 3 for x, so 3 to the 5th power minus 25. Remember that this is 3 times 3 times 3 times 3 times 3 minus 25, or in other words, 243 minus 25. Final answer is 218. For this one, I'm plugging in at 3x, so this becomes 2 times 3x plus 4. This is 6x, and these are not like terms, so I'm actually done. I can't combine them. On the graph, this tells me that x is equal to 5, and when that is true, what is y? If I follow it over, it's negative 3. This tells me when x is equal to negative 6, which is right here, if I follow that up and follow that over, what is y equal to? 9. The independent variable is the number of months, and the vacation days is what depends on that value. Here we look for the recurring cost, that's the $3.50. So we'll write that in function notation. And the 125 is the one-time fee. And that's the one that goes here at the end, not next to x. To figure this out, I can plug in 2. 2 squared is 4, times 3 is 12, minus 2 is 10. This one's on the line. If I plug in 1, 1 squared times 3 minus 2 is 1. This one is also on the line. If I do the same thing here, I plug in an 8, that's 2 minus 3. That's not on the line. If I plug in a 12, that's 3 minus 3. That's also not on the line. To find the domain and the range, I list all of the possible x values from smallest to largest, and I don't repeat. So here's a pretty good list for the domain, and for the range, I'll do negative 3, 1, 4, and 5. All of the possible x, all of the possible y, don't repeat. On the graph, though, I'm looking for a compound inequality. This is the leftmost point, this is the rightmost point. I can write that like this. The domain is anywhere from negative 4 all the way to 3, looking at the x values. On the range, I go from the bottom to the top. So the lowest value there is a negative 1, and the highest value is a 6. The domain here is anything from 2 all the way to the right, so I can say x is greater than or equal to 2. For the range, it's anything from 1 all the way up, so I can say that y is greater than or equal to 1. To identify the slope here, I consider 2 points and I look at rise over run. So here is 1 point, and here is another. I can go up 1, 2, 3, 4, 5, and I can go right 1, 2. Remember, I write this as rise over run. So that's 5 over 2. That's my slope, 5 halves. For a vertical line, the slope is undefined because that you can't divide by 0. For a horizontal line, the slope is 0. It never goes up or down. If you consider the pattern here, the x's are increasing by 1, and the y's are going down by 2. Remember, it's change in y over change in x. So that's negative 2 over 1, or just negative 2. To find this one, we take 6 minus 2 all over 2 minus 1, and that tells us 4 over 1. The slope is 4. For this one, they just ask us the slope, and the slope is the value right in front of the variable, or 3. Whole lot of words to ask that simple question. To graph this, I go left 1, down 3, put a dot. Down 1, put a dot. Right 1, up 1, put a dot. Draw a line connecting the 3. There's 2 key values to pay attention to. My b value is negative 2. My m value is negative 1/4. That's the slope and the y-intercept. So on the graph, I start here with negative 2, and from there I go down 1 and right 1, 2, 3, 4 for my next. I could do multiple if I wanted to, going down 1 and right 4, or working backwards. And if I draw a line connecting them, I'm done. Start with the intercept and use the slope. Think about rise over run. You rise a negative 1, which means you go down, and you run 4, which means you go to the right. If I wanted to graph this, I could plug in zeros, but I think they want me to solve for y first. So if I subtract 3x from both sides, I have 4y is equal to negative 3x plus 16. If I divide everything by 4, I have y is equal to negative 3/4 x plus 4. My b value is 4. My m is negative 3/4. So I start by going up 4, put a dot, that's my intercept. From here I go down 3 and right 4, put a second dot. Connect them with a line, try to be a little straighter than that, good to go. To write a linear equation, I'm going to start with my intercept, that's 3. Then I'm going to consider rise over run, that's 2 over 1, or just 2, how much I go up and how much I go to the right. To write this equation, I plug in the m value right here, and I plug in the b value over here. The equation is y equals mx plus b. So if I'm told the slope and I'm told the intercept, I can just plug those values in, and here's my equation. For this one, if I have a slope of 0, that is a horizontal line. Horizontal lines are always y is equal to something. Here the answer is going to be y is equal to 4. If you wrote it out with the slope, you could say 0x plus 4, and this part would just go away, and you would have y is equal to 4. Here I start with the equation y equals mx plus b. I'm going to plug in my coordinate here. Negative 2 is my y value, and 1 is my x value. My slope is 3/4, that goes there, and I need to solve for b. So if I subtract 3/4 from both sides, I have negative 2 and 3/4 is equal to b. To write my equation, I can say y is equal to 3/4 x minus 2 and 3/4. They say to write this in slope-intercept form, so I start off with this. I subtract 6x from both sides. I have 2y is equal to negative 6x plus 10. I divide everything by 2. I have y is equal to negative 3x plus 5. This is my b value. My slope is negative 3. I start by plotting 5. I go down 3, right 1, down 3, right 1. Draw the line. Here, my b value is 8. That means I start at 8. My slope is negative 2/3. That means I go down 2, right 3. Draw the line. If I look at the pattern, the x values are going plus 3, plus 3, plus 3, plus 3. The y values are going plus 2. So consider that I look at the change in y divided by the change in x. Y is a whole lot like f of x. They're the same. So my slope here is 2/3. What is my b value? Well, the b value is when x is 0, what is y? That's actually right here in the graph. B is just equal to 1. So I can write my equation as y is equal to 2/3 x plus 1. You have to find the m, find the b, and plug them in. To find the intercepts, I plug in the zeros. So I plug in a 0 for y, and I have 3x is equal to 9, or x is equal to 3. If I plug in a 0 for x, I have y is equal to 9, like that. For this one, for my x-intercept, I'm covering up the y's. And if I divide both by negative 2, I get 3. To find the y-intercept, I cover up the x's, and this is going to give me a 2. To find the intercepts, I'm always looking for the zeros. So this one is 7. And here I have 2 zeros. It turns out that this one is the y-intercept, and this one down here is the x-intercept. Remember that the x-intercept always has a y of 0, and the y-intercept has an x of 0. So the answer here is 12. The x-intercept is here, where the graph crosses the x-axis. It's at -1. The y-intercept is here, where the graph crosses the y-axis. It's at -2. The x-intercept is right here, where the line crosses the x-axis. It's at 1/2. The y-intercept is right here at -1. So let's first solve this for y. We get y is equal to 2x minus 7. M is equal to 2. A parallel slope is also equal to 2. Here, if I solve this for y, my m is equal to 2. A perpendicular slope, we take that 2 over 1 and we flip it, and I get -1/2. Flip it and make it opposite. 2 over 1 becomes 1 over 2 with a negative. To find the slopes that are parallel, I have to solve each of these for y. So we're looking for 2/9. I see that right here. If I divide all these by 9, this will also give me 2/9. Those are the parallel slopes, the ones that are the same. Here my original slope is 3/4. If I flip it and make it negative, I'm looking for -4/3. I see that here. That's one of the answers. And then here, if I divide by 3, that's going to also give me -4/3, so the bottom two are the right answers. So first of all, it's parallel to this line. That means that m is -2/5 because it has the same slope. So I start with y equals mx plus b, and I plug in x and y from the coordinate and m from the slope. So I have -1 is equal to -2/5 times 2 plus b. -1 is equal to -4/5 plus b. If I add 4/5 to both sides, I end up with -1/5 is equal to b. I put this all together, my slope first, then x, then my intercept. You had to write the equation, given the slope and the intercept. I start here with my original slope of 1. We can also think of that as 1 over 1. If I want to go perpendicular, I flip it, and I make it negative. So the perpendicular slope is equal to -1. Let's plug into y equals mx plus b. This is my coordinate, xy. So I'll plug in a 4 for y, a -1 for m, a 4 for x, plus b. So 4 is equal to -4 plus b. 8 is equal to b. I'm going to build my equation keeping these things in mind. The -1 comes here for the slope. The 8 goes over here for the intercept. And there it is.